Hi, everyone. I'm Qingtao Yu from Australian National University and the University of Queensland. I want to present our paper, When 3D bounding box means SAM, point cloud instance segmentation with weak and noisy supervision. First, let me introduce some background. Point cloud instance segmentation is a fundamental task in 3D analysis. The objective is to predict unseen dataset point cloud with the instance and semantic labels. Because point-wise annotation is very hard to annotate, so bounding box weakly supervised annotation is getting more and more attention. However, bounding box is very hard to label accurately in a complex sense. So we introduce our work to tackle this problem, and our proposed method is able to handle noisy bounding box problem. Previous work using such pipeline to do the bounding box supervised instance segmentation. However, we found this part significantly affect the result. And if we can improve this part, it might help to improve the noisy bounding box problem. And the reason previous work drops performance drops very much when a noisy bounding box exists is because this step. Our method is to use large 2D foundation model, segment anything. Segment anything is able to input prompts and output a mask. The overview of our pipeline is as follows, and I will introduce them by detail later. First, we have to initialize candidate points. The candidate points is initialized with the information of superpoints, which represents the 3D geometry architecture. And then we design a 3D confidence ensemble module. And this in this module, we first do a greedy view selection algorithm to select the point projection views so that every point can be visible in the selected views. And then we introduce complementary prompt generation module. For this module, we use the projected points to generate two kinds of prompts. First is foreground prompt, and the other is background prompts. And then we use a segment anything model to get the predictions of both kind of prompts. And then we merge the prediction together to get a final prediction. Then after this step, we input the SAM predictions of all the views and put it into a confidence ensemble process. And then we can have point-wise instance labels very accurately. In the final step, we put this we put this accurate instance labels for a fully supervised instance segmentation network. Because fully supervised instance segmentation network is very powerful, so our result is very high. First, I will show you the quantitative result of our method. Under the noise-free bounding box scenario, our methods output the existing work significantly. And our main advantage is when handling noisy bounding box inputs. And as we can see on Scannet-v2 dataset, our method outperforms the baseline significantly. And we also show that with our method, we can get very accurate point-wise instance labels. And finally, I want to show you my qualitative results. as you can see from the graph, our method can significantly improve the label accuracy as squared by the yellow boxes. So because because we use the advanced performance of 2D foundation model SAM, so we can have very accurate instance point-wise labels, and with a fully supervised network, and we can get a very good segmentation result. Thank you very much for the listening.